So we're going to talk about the dot product of two vectors. And so we're going to take two vectors. The first one is A. It's equal to ax times I hat plus ay times j hat. I hat is a unit vector in the x direction, and j hat is a unit vector in the y direction. So a unit vector is a vector of length 1, and so this is I hat, and this is j hat. All right. And so we can write any vector this way. If we would have a plus az k hat if we wanted to out here. Similarly, b is equal to bx I hat plus by j hat. So for example, if I had a vector that was, if I said a is equal to 3 I hat plus 2 j hat, we would do 3 in the I hat direction, so 1, 2, 3. So here, and 1, 2 in the j hat direction, and that would be our vector A, right? And so I can write any vector in the xy plane in this notation, and here are two of them. So the definition of the dot product, A dot B, is equal to ax bx plus ay by. That is to say, it's the product of the x components plus the product of the y components. If there were a z component, they would be plus the product of the z components. And so it turns out this is equal to the magnitude of the vector A times the magnitude of the vector B times the cosine of the angle between them. And so you can see that by sort of writing these out. The magnitude of the vector A is equal to the square root of ax squared plus ay squared, right? And the magnitude of the vector B, the magnitude of the vector B is equal to the square root of bx squared plus by squared, right? That's the length of those vectors. Well, so what is the cosine of the angle between these two vectors, right? And so let's talk about that for a second. So let's say I have two vectors, right? I'll just put them in the first quadrant for the sake of argument. So this is B, and this one is A. And so this is the thing we're calling theta here, right? This is so this dot product, we're saying it's defined this way, but we're saying it's also equal to the magnitude of A times the magnitude of B times the cosine of the angle between them. This quantity comes up a lot in physics and engineering and other fields, where you want the product of the magnitudes two vectors times the cosine of the angle between them. And we're going to show it's just the dot product. It can just be evaluated this way. And so I'm going to call, let me get a different color here. I'm going to call this guy theta B, and I'm going to call this guy theta A, and I'm going to say theta is equal to theta A. Turns out it won't matter, but I'll say theta A minus theta B. And so what we want up here is actually, what we have is, A dot B is equal to the magnitude of A. What we're saying is times the magnitude of B times the cosine of theta A minus theta B. It turns out, of course, that you can flip the sign of the argument to a cosine to get the same answer. That is to say, cosine of 45 and cosine of minus 45 are the same. So it doesn't matter if you write this as theta B minus A or theta A minus theta B, you still get the cosine of the difference between them. We already know what these guys are. These guys are written here. And so what is this? Well, if you use the difference formula, this is cosine theta A cosine theta B plus sine theta A sine theta B, right? That's what the difference formula is for cosine. sorry, I have to get my A and B in here. Right, well, the cosine of theta A is just AX over the magnitude of A. Right, it's just adjacent over hypotenuse. Right, the cosine of theta B is equal to BX over the magnitude of B. Right, and finally, similar for the sines, right? Sine theta A is equal to AY over A, and sine theta B is equal to BY over the magnitude of B. And so if I write all this out, this thing here, which is A dot B, you could substitute in these guys if you want, or you can just write it this way. You can say, look, that's equal to the magnitude of A times the magnitude of B. I'm running out of ink. Here we go. Times this thing, it's just AX over the magnitude of A times BX over the magnitude of B plus AY over the magnitude of A times BY over the magnitude of B. Notice these guys cancel with these two, right? That's a times, and this is just AX BX plus AY BY, which is what we had here. And so the dot product of A and B is just the magnitude of A times the magnitude of B times the cosine of theta. Sometimes it's easier to evaluate it this way. Sometimes it's easier to evaluate it this way. This is sort of the way it's defined. And so just to give you one just sort of simple example, right? How this is often used is we could say if A is equal to 2I hat plus 3J hat and B is equal to 4I hat minus 2J hat, then A dot B is equal to 2 times 4 minus, or I say plus 3 times minus 2, right? I multiply these two guys together, and I multiply these together, and I add them, and so that's equal to 2. And then the magnitude of A is the square root of 2 squared plus 3 squared, right, which is the square root of 13, which is about 3.6 or something like that. And then the magnitude of B is the square root of 4 squared plus 2 squared. If you want to say minus 2 squared, you can, but it still comes out as 2 squared. And it's the square root of 20, which is about 4.5 or something like that. And so I can say, look, A dot B is equal to the magnitude of A times the magnitude of B times the cosine of the angle between them, right? And so I can say cosine of theta, cosine of the angle between these two vectors is A dot B over the magnitude of A times the magnitude of B, which is A dot B is 2, over 3.6 times 4.5. I'm going to do that on my calculator. Um, 16.2. So it's 2 over 16.2. 0.123. Or about 83 degrees. So this is so it's just an example of how you do dot products. There's how you calculate the dot product, and then you can just use that information if you want to figure out the angle between these two vectors, this one and this one. And it would be hard to do that without this. You would have it would be challenging to draw this vector on a graph and that one and see what the angle is between them. And so the dot product is often, at least in like trig classes and stuff like that. I don't know where you use it in the math curriculum, but we use it in physics a good bit for calculating angles. If you know the definitions of the vectors in Cartesian coordinates, you can use it to calculate the angle between the two vectors this way. So anyway, that's just a short thing on dot products and how they work and how to calculate them and what they're used for.